Welcome to Bite-Sized Data Science. In the context of data collection, I feel I have to talk about relational databases. Relational databases have been around for a long time. They displaced files and hierarchical databases as the dominant data storage. There were multiple reasons for that. They provide a way to address multiple problems with the same data instead of solving only one problem very well with hierarchical databases. They allowed for concurrent access and concurrent updates of the data, something that files could not do. They introduced simple data access languages, where eventually SQL became the dominant language. Still, despite these benefits, there was always a group of people that tried to discredit or even kill relational database systems. At first, people said that the relational databases were too resource-intensive to be used in enterprise applications. They said it would require specialized hardware to make it work. Eventually, technology improved, algorithms improved, and relational databases took off. The next major attack I can think of was in the mid-80s. This is when the object relational approach became popular. All of a sudden, everything was an object. Objects would include other objects. Objects would inherit from other objects. Objects were so magical that we needed a new type of repository for them, object databases. According to some, relational databases were inadequate to store objects. There was an impedance mismatch between objects and relational databases that was too great for object programmers to comprehend. Eventually, relational databases prevailed. The next attack was when XML became the new solution to our problems. People started talking about XML databases. XML databases had momentum until people decided that XML documents needed to get validated through XML schemas. The idea of XML databases lost popularity. The last major attack I can think of is with the introduction of MapReduce and big data. The idea here is that we have a lot of data and we need to process it all. The solution is to use large clusters of commodity hardware to do it using the MapReduce method. In parallel to that, there was a movement to promote NoSQL databases. Eventually, the No in NoSQL was said to stand for not only SQL. Still, when you hear NoSQL, that's not what comes to mind. People realized that MapReduce was difficult. Spark came to the rescue with more built-in capabilities that made it easier. Finally, after the introduction of Spark data frames, the solution to making Spark understandable to the masses was Spark SQL. It's kind of funny to see that the solution to MapReduce ease of use came from relational databases systems. Funny and instructive. Why all these attacks on relational database systems? I see two main reasons for that. The first one is that we have a tendency to think in terms of hierarchies. Think about the taxonomy we use to classify living things. What about organizations? Where did the attack came from? At first it was from hierarchical databases, then from object people. Objects are hierarchies in terms of inheritance and also in terms of containing other objects. XML and JSON documents are also hierarchies. The second reason for the attack on relational databases is freedom from constraints. Programmers don't like constraints. They want to do their thing their way. This is particularly obvious with what happened with XML repositories. As soon as the industry decided that we needed to regulate XML documents through schemas, people did not like them anymore. There is a tendency in the computer industry to go for the new shiny thing and dismiss previous technologies as inferior or even irrelevant. The thing is that relational databases systems are based on elegant concepts that were defined decades ago, but that does not mean that they did not evolve. Over the years, we saw the addition of stored procedures, object relational technologies with new indexing methods and data types, the ability to run a logical RDBMS over a cluster of machines, and taking advantage of large memories, compression, and more. Relational database management systems are state-of-the-art technology with well-known and easy-to-use interfaces. There is a large pool of people that already know SQL. Then there is also the fact that SQL is easy to learn. I think that if you have less than 1 petabyte of data, you can continue to see RDBMSs as a key technology in your data science projects. See you next time on Bite-Sized Data Science, and don't forget to subscribe.